we need to talk about? We need to talk about, I already showed you where sine and cosine were, and so I'm going to write that down explicitly. The cosine of any angle on a unit circle, this is on a unit circle, so any angle I give you is going to be the x-coordinate I can't spell coordinate today. Of the ordered pair. So this is on a unit circle. The reason that's true is because the relationship between the sides and the hypotenuse on a cosine of an angle, it's the adjacent side over the hypotenuse. And on a unit circle, the hypotenuse is always 1. So if we look up here, you know, no matter how my triangle is situated, the angles come from the origin, and so they're always going to have the adjacent side be the x-coordinate of their ordered pair. It's going to be this length here. No matter where it is, it's going to be this length. Okay. Sine is the y-coordinate. How do I remember this? Sine is whiny. Oopsie. Sine is whiny. So that's my silly little absolutely doesn't make any sense saying to help me remember which one is which. And that's because it's opposite measure over hypotenuse. On a unit circle, the hypotenuse is 1, so it turns into just the value. And what do you see opposite the angle is the vertical measure. Like this. I look opposite, it's that vertical measure, vertical measure, vertical measure, vertical measure, vertical measure, vertical measure, blah, 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 all vertical measures. That's the opposite side, so that's why the y-coordinate is given that tells me the value of the sine. Then the tangent, you have to do a little math. You take the y-coordinate over the x-coordinate, and that's because it's the opposite over the adjacent. And that should like ring a bell. How am I going to remember which one's in the numerator, which one's in the denominator? It's like a slope formula, right? You have the change in y's over the change in x's. That's how you find the slope of a line. That happens to be how they calculate the tangent of an angle. Just so beautiful. All connected. Relationships, relationships, relationships. Okay, so we're supposed to play nice and not use our calculator for our homework, but I would not throw rocks at you if you used it to check your work. So this little guy shows you how you can do it without your calculator. And we're going to evaluate trig functions for reference angles, and those are the reference angles. They are between 0 and 90 degrees. Okay, they're between those two measures. And one side is always the x-axis. That's the definition of a reference angle. Okay, so why do they have to define such a thing? It's because, remember, I could have an angle of 1,000 degrees, remember? So if I have to boil down that angle so I can find it somewhere on the coordinate plane, and then I see what angle it is, then I know closest to the x-axis, then I know which, remember, that's sine, that's cosine, and then tangent's the relationship of the two. And we already talked about this on our unit circle. And that's why I went ahead and did this whole unit circle story, because this, for me, this just wasn't enough information. Like, how do I know where that square root of 2 over 2 came from? Well, I showed you, and then I showed you where it was on the unit circle. So instead of pulling them out of the unit circle, I wanted you to see what it looks like in the unit circle. How do I know these are out of a unit circle? Because remember, the hypotenuse is 1. That's the definition of a unit circle. The radius is 1. So that is what they're talking about up here. So this is what you're supposed to do without a calculator. And obviously you're going to use a little bit if you're not, don't have good number sense. You want to change the angle to a positive by adding 360. If this was radians, you'd add 2 pi, right? Just like we did in 17.1. Then I find 135 on my unit circle, and then I see it's a 45-degree angle, but it's in the second quadrant. So if I want to find the y-coordinate of a 45-degree angle, that's where they get it. And it's a positive because here the x's are negative, the y's are positive. And all we have to do then, we can just look up, because we have this beautiful thing, we can look up for the y-coordinate on 135. You got the sign. Yeah. And then, yes, you put in the sign of negative 225 degrees. There you go. So this is a degree mode. So it worked for me. If I had it in the radian mode, I'd get a different answer. So if you don't get an answer that makes sense, if you're checking it on your calculator, it didn't match what you found, then you got to make sure your calculator's in radian mode. That's, the weakness of the calculator. You're in charge, garbage in, garbage out. You got to make sure you know how to change it from degree to radian. Okay? Got to know how to do that. So now it says RAD. So you just hit the mode and then slide it over. I'm going to hit it back to degree because that's all the examples they have here. But I want you to see where this comes from. If I just give you the calculator, you hit the buttons, you have no idea what this means. So if I want to find the sine of 420 degrees, I'm going to change it into an angle that's between 0 and 360. Okay, so I'm going to look for the y-coordinate, siney is whiny, of 60 degrees. So I look here, 60 degrees, y-coordinate is square root of 3 over 2. And my calculator, I'm going to put in the sine of 420 degrees. There it is. They still want you to be able to read this unit circle. Now, not all things are found on the unit circle. In the homework, you'll start with angles that are common on the unit circle, and then they'll take you out to angles that you can't have a ratio like this. You have to round a decimal. But this is a perfect measure of the sine function for 60 degrees, 420 degrees, whatever it is, okay? Okay, get your brain in the game here. You are finding a length. So you're going, who cares what the sine of an angle is? You found the length of the opposite side, and therefore you know how far it is to Mars. Okay, that's what the power of this math is. It's measuring things you can't walk up and put a yardstick on. The top of a mountain, even the top of the tree, a top of a skyscraper, places you measure an angle, you find the sine, and you've got the height of the structure. That's what you're doing, okay? So it's very, very very powerful. You know, the surveyor's office. This is our life. Okay. Now, what do I want to know? If I want to know how far away I am from that structure, then I'll use the cosine function. I measure the angle, and then I calculate. I got to make it positive. That's 240 degrees. So I'm going to take the x-coordinate, because cosine is x-coordinate, sine is y. 240 degrees. Okay. So 240 degrees, that's a 60-degree reference angle, 60 degrees from this guy. And so, you know, if you've got the two measures, the x-coordinate of a 60-degree is 1/2, but since it's in the third quadrant, it's a negative 1/2. And you can put in the original angle, cosine of negative 120, and come up with the same result, verifying your truth. You just found that distance. And the negative gives you the direction of the distance. So now we're talking vectors and all that goodness. Okay. All right, so I'm going to add 360. I'm going to look for the y coordinate. I'm being lazy, abbreviating it a little bit. The y coordinate of 300 degrees is a negative square root of 2 over 2. Oh, I'm reading the wrong one. Negative square root of 3 over 2. Sorry. There we go. Okay. 300 degrees, it's above its line. So there's where I got my math. And again, verify my idea. Put in, I'm doing the sign of negative 60. There we go. Take away 360. That's 135 degrees. The cosine is the x-coordinate. And that is a 45-degree reference angle. So the x-coordinate of 135 is a negative square root of 2 over 2. Because up here in the second coordinate where 135 degrees is, the cosine's negative. So there's that game. There's that game to play, but we've got a unit circle, so we can just verify along with our calculator. Cosine of 495 degrees. Okay, let's get into the homework. Now we have a chance. I'm only going to do a couple because of the fact you can check with your calculator. I'm not going to bore you with my calculator checks. I would just want to explain what they're asking for, and watch out that you have your calculator in the right mode. You want to go there. We just figured this one out. What a nice coincidence. Remember, I'm looking for the x-coordinate on my unit circle. And I do know, you know, you might get into a math class where they won't let you use the calculator. So we just don't want to depend entirely on the calculator. They want you to understand the unit circle. And reference angles as well. Okay, number 2 is a tangent, so I want to show you how to find that.
Staff, if you want to take your 5th period students outside about 10:27, that is fine. Then when we do the send off, we can send in the 6th period. Thanks, goodbye.
Okay, I wondered about that. Okay, so here we go. Tangents the y value over the x value. If I add 360 degrees, I get a positive 350 degrees. So I'm going to put my y coordinate from 315 degrees. That is negative square root of 2 over 2 over square root of 2 over 2. That's why the calculator, if you put it in, you're going to get a negative 1 for an answer. Okay? And we'll march on tomorrow.